It's been said that beauty is in the eye of the beholder. We could say the same thing about the color green and its meaning on the radar display. The fact is, depending on your manual operating techniques, green may mean very different things to different pilots. For instance, in low reflectivity environments, some flight crews use a low tilt setting and max gain, and then avoid all weather that paints yellow or red, under the assumption that the threat reaches to their altitude. In these instances, when auto paints the cell green, the crews consider that the radar is under warning. However, other crews in similar environments use a higher tilt setting and calibrated gain. In these cases, most thunderstorm cores paint green on the display, and these green cores are considered a substantial threat. When MultiScan paints the core red, as in this picture, and the edges of the cell are displayed as yellow and green, these crews consider the radar to be overwarning. As we learned in Module 1, MultiScan uses variable temperature-based gain to better detect low reflectivity thunderstorm tops. The end result is that most flight crews will see more than they are used to seeing when using the radar in auto. This series of pictures is taken over the Gulf of Thailand. Note that in manual mode, in calibrated gain with a -2 down tilt, only thunderstorm cores are shown. When manual max gain is selected, a weather ridge line is visible to the flight crew. Because the Gulf of Thailand is a low reflectivity environment and cells are difficult to detect, auto cal gain is actually more sensitive than manual max gain and displays more of the cell system for the crew. So, here are some guidelines for interpreting the radar display, and especially the color green, during automatic operation. First, let's consider low-altitude operations. There are many times where the color green is not a threat and indicates at most light to moderate chop. For instance, consider this picture where the entire display is green. At lower altitudes, this occurs during stratiform rain conditions, and little to no turbulence is present. At lower altitudes, there are occasions during certain unique meteorological conditions where the display may turn completely yellow or even red, which is sometimes called redout. In this instance, the aircraft is right at the freezing level, and melting snow has formed an area of strong reflectivity, turning the display yellow, even though there is very little turbulence. A similar situation sometimes occurs during monsoon rains, where heavy rainfall rates produce very strong reflectivity. Remember from Module 1 that every 10 dB of gain represents one color level. Therefore, should flight crews encounter a situation such as this, gain can be temporarily reduced by 4 clicks, or about one color level, to better determine if embedded cells are hidden by the heavy stratiform rain. During high-altitude operations, interpretation of this picture changes. In this case, a broad area of green may indicate high-altitude ice crystal conditions. As this satellite picture shows, ice crystals can be present over a broad geographic area. These ice crystal clouds have resulted in TAT anomalies and engine power loss. The new high bypass engines appear to be especially susceptible. In this case, the aircraft transiting the area experienced TAT anomalies about halfway through the ice crystal region, and the anomalies stopped shortly after exiting. Initial flight tests and incidence reports have shown that when in auto, the radar's variable temperature-based gain function often displays these ice crystal clouds. If a broad area of uniform weather such as this is displayed at higher altitudes when using the radar in auto cal gain, crews should consider this a potential area of high-altitude icing. Exit the region as soon as practical and initiate the Boeing high-altitude icing radar procedures. As can be seen by this view out the captain's window, the radar is displaying weather at 25 nautical miles. In this case, green represents a pressure ridge, and the flight crew can anticipate light to moderate chop when the aircraft transits the region. However, the two fingers that extend to the right of this storm core indicate an internal shear force. Even though these returns are green, they still represent a threat to the aircraft. In fact, this dark area between the two fingers is an indication of a hail shaft and should not be transited. This 787 display shows normal thunderstorm activity. The circular shape of the cells and the normal gradient between colors indicates convective activity but no unusual threats. In this case, green represents the outer boundaries of the cells, and the pilot navigated between the two cells containing yellow cores. By way of contrast, the irregularity of these cells indicates significant shear activity, and the very steep gradient between the colors is typical of very strong convective lift. Once again, these U-shaped areas represent possible hail shafts. With regard to these cells, green is a good color to avoid by a wide margin. Increase in green returns will also occur as weather nears the aircraft. By way of explanation, let's examine radar beam attenuation. When a radar pulse leaves the aircraft, some of it is scattered and absorbed into the atmosphere. This attenuation of the pulse grows in magnitude as the distance of the pulse from the aircraft increases. In addition, beyond 80 nautical miles, thunderstorms no longer fill the beam, and further attenuation occurs because there is less power on target. This means that at long range, the radar will only be able to see very strong weather, such as thunderstorm cores. As these storms approach the aircraft, more of the cell becomes visible. In these pictures, note how the radar sees the line of cells at 300 nautical miles. As the cells approach the aircraft, attenuation is lessened, and more of the full extent of the storm becomes visible to the radar. What this means is that it is not unusual for storm cells to fill in as they approach the aircraft. In fact, due to features such as geographic weather correlation and automatic temperature-based gain, the radar now sees more of the actual extent of the storm than could be seen with older radars. Note in this picture that at 50 nautical miles there is a gap between the cells. However, when the cells are at 40 nautical miles, the radar attenuation has lessened, and it can now see the green haze between the cells. There will be occasions, such as this, where a transit corridor between two cells fills with green as the aircraft approaches. Again, remember that in these situations, green normally indicates light to moderate chop and can be transited. In summary, when interpreting the color green on the radar display, perception as to whether the radar is under warning, overwarning, or just about right will depend largely on your previous manual operating techniques. However, in most cases, due to the radar's use of variable temperature-based gain and geographic weather thresholds, most pilots will see more information than was previously available. Remember that in many cases, green represents at most light to moderate chop and can be transited. However, pilot interpretation of the radar display is still critical for avoiding significant convective activity. In this case, shear forces associated with an adjacent thunderstorm represent severe weather and a possible hail shaft. Also, normal cells are circular or oval in shape and have normal gradients, while irregular cells with steep gradients represent a severe threat. If a red-out condition is encountered that saturates the display, turn the gain down by 4 clicks, or about 1 color level, to check for embedded cells. After momentarily analyzing the weather, return to the cal gain position. At cruise altitudes, a region of green on the display may represent high-altitude ice crystals. Exit the region as soon as practicable and initiate the Boeing high-altitude icing radar procedures. Finally, remember that as the aircraft nears weather, there will be less attenuation and that more green returns will become visible.